Okay, I think it is able to capture the whole image of myself. And right now I want to share this is what you see here is my lab. And I was here in the last 2 years and doing my research in the cryosurgery area. I'm very glad to be in this lab. You can see there's a very empty, empty in people, not empty in equipment. And you can see this is or this one is I don't know, I haven't used since I was here. And this is my experiment setup. My experiment setup is basically very simple. You just have a nitrogen tank. When I use it, I order from the company and it is in. But now I'm not going to do the experiment, so the nitrogen tank is not here. Also, after the nitrogen tank and the liquid nitrogen from the nitrogen tank is going to flow inside what we call a probe, means cryoprobe. And inside the cryoprobe, the liquid nitrogen, we assume it is going to evaporate and release the cold, ultra cold, extremely cold temperature to generate extremely low temperature at the tip area. So in that way, when the liquid nitrogen comes in and comes out, evaporate and have a very low environment here. So this is the core part of the cryoprobe, and we built the cryoprobe ourselves. This is whatever the cryoprobe I use right now was designed by myself. And the cryoprobe inside of a tissue, and is going to release this low temperature to the nearby tissue, and the low temperature is going to kill the cell itself. After this liquid nitrogen has been evaporated, it has been transferred into a we call pressure stabilizer to stabilize its pressure, because it is constantly have the two-phase phenomena there. The liquid nitrogen is constantly changed to the phase, change to the gas phase, and in that way we have a container. When the liquid nitrogen and gas nitrogen, they come inside this tank, and it is able to generate heat exchange and phase change inside of this pressure stabilizer. This stabilizes the pressure and then go to the temperature wall spot. Temperature control bus. Temperature control bus, it has a certain temperature, and the temperature by itself, it can be 40 degrees, so it is enough to evaporate all the liquid nitrogen. And the liquid nitrogen, when it has been evaporated, and the back pressure must be very high, and when they evaporate, the back pressure has been transferred back to its upstream. That is why we have the pressure stabilizer right before the temperature control bus in order to control the temperature, to prevent the temperature stabilized to rise intensely to influence my cryoprobe temperature. And after this, we make sure that all the liquid nitrogen has changed into the gas phase, and this gas phase liquid nitrogen has been exhausted outside the window. And this is the upstream, this is the stream of the liquid nitrogen. And in order to measure the temperature, we also have different thermocouple inserted inside the tissue and measure the tissue temperature at different locations. Besides, we have the infrared camera, and we use the infrared camera to capture what is going on. That means that in terms of temperature development. Basically, this is our experiment setup. Of course, we have different pressure transmitter to record the transit pressure change. And we find that the pressure stabilizer it is very useful in terms of reducing the variability of the pressure. And that is the experiment setup. And we have a lot of trial. We buy a compressor. Not a compressor, it is just a vacuum pump. And we use it to vacuum the downstream pressure. We want to test whether a lower downstream pressure is able to generate better performance. But the capacity is too low, and I extract it, and I cannot lower down the pressure because the liquid nitrogen, it becomes a gas phase. It has a large volume change, volume increase. So it's just like to suck the liquid nitrogen gas phase, the gas phase nitrogen into my vacuum pump, so it doesn't work. And beside of that, it also have another water bus. It is going to generate the warm water flow inside tissue. We use it to simulate the vascular effect. Vascular effect is very important because it is enough to induce certain heat up area and to prevent this area from the ice frozen, from the ice formation. So in that way, we simulate why and how this blood network is going to affect the cryosurgical efficiency. That is my experiment setup, and we have a different improvement. And right now, we buy a new product. It is RFA, radio frequency ablation. We use this radio frequency ablation. The benefit of the radio frequency compared to the cryosurgery is its probe is very, very tiny, very small. So in that way, they can have a very minimum impact in our tissue. And of course, the lethal area is also very small. Compared to the cryoprobe is a little bit larger, but the ice ball formation is also large, and the cryoprobe is also large. So they are hard to say which one is better, but they have their own advantages. We plan to incorporate them together to generate a hybrid cryoprobe. And let's see the performance. That is probably my last experiment I'm going to do. Maybe take a look at my experiment setup. Okay, right now you can see here is my experiment setup. The biggest, this is the water temperature bus. It is going to use it to generate the blood vessel. To generate the blood, warm water as the blood. And what you can see here is the cryoprobe. The cryoprobe with several thermocouples, and I buy new thermocouples. The older ones, some of them cannot working properly. And this is some pressure transmitter. This is a data log, and the data log is use it simply to collect the data. And this is the pressure stabilizer. What I feel is you can see the bracket. This is very, very simple, and we are building a better bracket to hold it. And this is another water temperature bus in order to change the liquid nitrogen into the gas phase. And basically that is just a very simple experiment setup. And I use it to generate some journal paper before my graduation. And what you can see here is the whole thing here is very, I'm saying it is well organized. This is the place. Maybe 10 years later, when I review this video, I can feel, oh my God, this is the time. This is the time I make a difference, make impact. And a wonderful time in my life. And let's look at the other ones. And what you can see here is this is the undergraduates. They usually do things here. This is the door, the entrance. Oh, I forget almost that this is my computer. I use this workstation to generate a lot of simulation. And also I have cameras inside in this cabinet.